Hello students, in today's class we learn about mechanical vibrations, how mechanical vibration works, what are the main systems we consider and how it is considered, why mechanical vibrations are oftenly taken as the most toughest subject, but it is not so because the approach is not always the same. So what happens is it becomes more tougher, and for which they doesn't know how to approach the subject and to do the sums as well as the understand what are the things. So this is a natural phenomenon. This will happen in every mechanical things. So you may ask that it's vibration a normal thing. Yeah, vibration is a normal thing because we have studied in the particle physics also that particle have wave as well as anything can have a particle as well as wave nature. So that means, what does it mean? Wave nature is nothing but your vibration. So everything consists of vibration, so you have to take in granted. So some vibrations are encounterable or calculatable, but in other but all are not so you can't calculate. So because there may be a precision effect, or there may be other things like other effects which will become and which will come and cross that vibration or cancel out that vibration. So a cancelling of vibration totally is impossible. So it's just a talking that it could cancel. So because 100% idleness in the entire universe is not possible yet now. So this is one centrifugal pump. So what happens is, as you can see, that if you this is a picture of an instrument which we use to find out the RPM of the body of this pump. So what we do, we fix this point to over here, and when the pump rotates, we could see the changes in the RPM and so let's the vibrations also. This is what we want to show. Okay, so similarly for the gearbox in a car, the cylinder engine, so everyone you will get this one. So what is the basically how we approach this problem, the problem of vibration, and how did you came to know? So when a machine is given applied some energy, then it will give an output energy in other form. So machine is nothing but a converter, but while converting there is some loss. So what happens, the loss as well as the loss makes the most of the vibrations. So there may be damped, undamped, as well as the vibrations what we have, the losses can be its fundamental loss, as I have told you so earlier. So this can be the vibration. So vibrations can appear from any region or any circumstances. Okay, next. What is mechanical vibration? As I have told, its scientific definition is nothing but oscillation of motion. As I have told, the vibration is nothing but disturbance of the particle. Now it can be a micro or it can be a macro. That means it can be from a small subatomic particle as well as to a big International Space Station also. So this is what can be. So this is the actual thing, that is the oscillation. Oscillation means the change in the position in the single. So after getting energy, it get excited, then the energy it loses, again get excited, loses energy. So this is what happens. This is the simple method to understand vibration. But in terms of engineering, mechanical engineering, the vibration terms gets changes, because here we have to see in terms of forces applied. So what we can say that it deals with the vibration, the force acting on a body or a system. So what happens with respect to that, there can be a oscillation motion, or there may be not. So majority we get oscillation motion, for which there may be a certain distortion. So that distortion is termed as vibration. So that is, distortion means it is having a movement from with other aspects. So objective vibration, as I have told, a dynamic system matters, which for getting a vibration you need to have mass, that is mandatory. And elasticity should be capable, because the most if the elasticity can be if persist, then the vibration can be absorbed and it can be eliminated. But if not, it may destroy the system. The system can be the system of that can be very simple, or it can be very complex. Oscillation or oscillatory motion may be objectional. Well, that means the oscillation motion only can have vibration. This is objectionable. So it depends on the system, how it is, or no, how it is may not. So you have to see, you have to observe it first. So this is what the things will go while learning. So example of vibration, as I have told you so earlier. So this is are the three mass: red, green, blue, and they are connected with simultaneously spring. What happened is they they oscillate from one point to one, from the initial point to the final point, initial point to the final point. So we'll get a graph over here, which will make us understand how the changes, how the mass is oscillating, or it is jumping from the higher end to the lower end. So it is fixed on the down, that means it will come and drop over here. It is fixed on the ground, this three mass will drop down here. So how it will drop down? It will come and drop down, and it will again go up. So that means it will gain energy again. So this is what the graph will be, like sinusoidal or cossoidal. Okay, so there are few vibrations that you should keep in your mind. In according to the forces applied, you could say there are few vibration and force vibration. If force is if you are applying a force to maintain the equilibrium, so there will be a few vibration, that is termed as free vibration. But if you are applying a periodic force, that means a force after a minute, after somewhat beyond the equilibrium, then that will be your forced vibration. So what is the frictional dissipation? Frictional dissipation is that nothing but your energy. So here the energy is neglected. The energy is neglected. That is nothing but it depends on the frictions, as well as there is one more catch. I'll be telling you. The, energy is neglected in some matter, but we also consider energy in terms of mass. That gives us to be the motion to be undamped, and so we could take in according that most of the vibrations are damped in some degree of freedom, but in terms of energy that may not be, they may be undamped. What does it mean? Damped means we just residual vibration. That means the vibration will be an additional product of the system. Undamped means it will not be an additional product. So this is what I mean to say. Okay. So free forced vibration, as I can say, this is a freely movement, and you can see that this is moving at freely. So there is a vibration is free, undamped. You are not damping it, or that means you are not restricting it again. But in terms of damped free vibration, you are restricting with a plunger or a you may say by applying a force or by applying some a piston. So same goes for the force vibration. What where we apply a force, we give force to go for the vibration system, for vibration to work. This is what the diagram means. Here the force is working, here a force is applied with respect to time. So this is again this diagram where you can see that it will come down and it will settle and this graph will be observed. So it's very simple. Okay, you will get this things. So this is what happens, that most transient motion where vibrations are free, that means it will evenly die out, and that means die out means the vibration will be cancelled. The motion transient vibration motion. So what happens in a transient motion, we are not in transient motion, the vibration changes from one point to another, so that is in the horizontal plane, that works in the horizontal plane where vibration somewhat time get cancels. So this is what we could see, but in terms of steady state response, we know that the vibration is sinusoidal, or it changes with time. So this is but it tries to be in uniform, since it's a steady state response, because it gives a steady state responses. This is what we want to mean. Okay, sinusoidal vibratory motion, as you can see that this is the vibration counter what we have got, and this is our undamped and this is our damped. This is our damped, and so this is our damped. That means this is much more damping has been done, or in other words much more amplification has been done, but which is very critical, and as you can see the critical damping also. That means these two are a very risky point, and these things are no doubt it's a good yet right now. So this will follow a sinusoidal wave. So we consider it as a sinusoidal wave for mathematical purpose. It's not that you can't do in other way. For mathematical purpose it's very easy. So natural frequency. Natural frequency, as we know that there is a natural frequency or undamped free vibration. So what happens is everything has a natural frequency, that it exists. We know from the quantum physics that it exists. So what we know that how it happens due to the kinetic energy inside it as well as the internal energy. So the exchange of energy, what is happening, simple harmonic motions, everything we have to consider. That gives rise to natural frequency. So damped, as I have told you, that spring mass system where we apply a damper, or we may say that a piston which damps the complete vibrations. So this gives a new way out. So element of vibratory system, as I have told you, inertia, elastic, energy dissipate element. That means mass, spring and damper. These three are the majority things to simulate the vibrations and to understand. So this is used to simulate it, because mass is the property of the material, is the particle which will be under the vibration. Spring, this will simulate the vibration, and damper or a piston like things which will decrease or increase the vibration quantity, or as well as maintain the vibration system. Okay, mass, spring, damper, as I have told you. Okay, an example of vibration, as I have told you. So there are three types of vibration: axial or longitudinal, that is to axial of a body, or longitudinal, lateral or bending. So it depends on bending or not. Next thing is the torsional or rotational vibrations. What happens? This is a lateral vibration. That means it goes up and it goes down. And axial means this will rotate. This goes from, she slides from here to here, here to here. This is what torsion means. This will move from this, this will plates moves, and hence this shaft gets a torsional effect. So axial vibration, as I have told you, this is the axial vibration, where the vibration effect moves from axial. Okay, axial vibration, as well as you can see. So we give here damper. So as well as the vibration on the shaft with pulleys can have, as well as this one, this piston system, piston can also have this axial vibration, because it will go up, it will get a force, and it will again come. So there will be losses, and hence there will be a vibration. So let's say lateral vibration. This is an aircraft engine which got laterally vibrated and maximum distorted, this one. So this is what you can see, and this is also a vibration, vibration effect of of a bar, which you can see over here. So lateral bending vibration. So here you can see that this was some types of bending also, as you can see, as well as bending. So what is happening? So this get bent like this, or this get bent from like this. So this what happens. So here you can see bend. So I have to consider the bending stress over here. So again, torsional or rotational, the rotation of this one, or torsional of this shaft, or this rotational vibration. So nothing but this is a bar, and this is a bar. This rotates. So LS dyna was used for air value of 1 second to understand. So I'll show you in the next class. Vector representation of harmonic motion. So how we do? We just simply do one thing. So we know that it goes up. So I'll give the maximum value. It goes down. So I'll give the minimum value. So the graph comes in a sinusoidal manner. Because it starts from here 0 to, as well as it ends down to here. That's why it's 0. So this gives me a sinusoidal curve. So this is the period or total period where it gets high to lower. So this will actually help me to understand how it works. So the simple harmonic motion will give me the idea. So after that, what I can do, I could go for the other things with time, with respect to time. So what happens is, the respective has the following parameters, as you know: time, frequency, and amplitude. What is time? The time is from here to here. What is the time? Amplitude, fine, and frequency, how it is happening, how is the frequency is more or not. This is what. So after the three components we'll be putting, like here, this bar is initial position is this one. For maximum upward, it will go down, up this, and lower this will go this way. So peak acceleration, peak velocity, and time, this will give us this one. So definition of parameters, as I have told you: time, period, frequency, and amplitude. So this is order. So time period, I know that tau is equals to 2 pi by omega. So what is omega? Omega is the circular frequency, or in other words, we say the you may say that circular angular velocity also in some terms. So frequency f is equals to 1 by tau is equals to omega by 2 pi. So what we can do? So if we represent in the terms of xt as a change in, so I could say xt is equals to x cos omega t. The velocity is equals to differentiation of this one minus omega x sin omega t. Acceleration, double differentiation of this one, we get minus omega square x omega t. Why this one? Because to understand this factor, we have to go for the trigonometric values or the functions. So that's why we have done this one. Okay, a sine curve or the combination, as I have told you. So this is what is it? Sine and cos, anything can be used, or both can be used. Like here it can be over here x1 sine omega t, x2 sine omega t, and this will give me this one. These are just mathematical part. It's not even physics or mechanical part or engineering part. It goes from to what's mathematical part. Very easy. As you can see, the graph of cosine and the sine, so they two get add up and we get a sine curve. So this is what we will understand. So again the vector representation. So this will be omega, and there will be one angular thing. So this is what we do. X is equals to x omega is to x e j w t, where the length of the vector j is equals to root over minus 1. Consider as well as again x is equals to cos omega t minus the velocity integration differentiation velocity double differentiation acceleration, hence the result. So this is what happens. This is x, this is omega minus x, and this will give you everything. So what are the causes of vibration? So parallel misarrangement, that is, if you need to if the things should be, if the misarrangement of the system has been done, or angular and misarrangement. So this is the this happens due to many things, due to self as well as misalignments also, alignments of the system. So rotating unbalanced centrifugal forces. So if a body is given over here, so this will also give you a extra mass, the extra thing, and an unbalanced system can also give you a vibration. Eccentricity, if shaft, wheeling of shaft, so this effect can also give you a your vibration. So this is the bending of shaft due to wheeling effect. So this can also happen. Okay. Other factors like some that friction, wearing and tearing, broken parts of as you know. So this is what happens. So what you can see, this is the Tacoma narrow bridge disaster due to maximum vibration, and they have not considered damped vibration over here. So hence this used to rotate from here to here, here to here, and the breakage happened, and this caused the vibration vortex shielding, and it went up, as you can see. So last but not the least, it went. So this was a very bad experience of not considering vibrations, damped vibration in a proper way. Again, the wing flutter test of Boeing 747, and this was successful, and this showed that this wing, the greater the wing, so there may be an effect of vibration. So this is same for the wind tunnel also. So what we have to understand, that this gives a new era of designing aircraft, that more, if you increase the length of the wing, you have to be ready for this damp for vibrations, free vibrations at the end of the wing, and how you can manage it by using a drag or lift force. What are the effects of vibration on the machine and man? So we have, as I have told you, that it destroys the machine. It's sometimes it goes for failures, and this will make everything messed up. So this is what basic concept as a one, frequency, characteristic of geometry, how the geometry is. So frequency, as well as we have seen that inertia, what inertia is causing, what elasticity, either elasticity or, as well as the realistic addition is the energy dissipation, that means energy change in energy from potential to the kinetic energy. So you have to go for the energy characteristics also by using a damper. So this is the same method I told you. Resonance condition is a condition where with large amplitude, that is the vibration maximum, and where you can get many system may fail, so or may not fail. So vibration for a pressure or for a washing machine, and so on. This is what we can get. Okay, fine. The thing is that I will show you something more, then I end up with this session. So there are types of damped vibration. viscous, hysteresis, material damage, dry friction for Coulomb damping, damping with electromagnetic. So this is what happens. So vibration can be viscous, that is due to fluid, or material due to material, or dry friction, that is due to friction, as well as damping. It may be for damping or electromagnetic changes also. So you can't say the vibration can only be for mechanical, it can be for other things also. Hysteresis means the losses of material. So hence we know that Ft, F is equals to F omega t, same as we have done. We came to, so x is equals to F by changes in the responses. So this is mathematical response, k minus omega square m whole square minus omega square. So dividing both sides by k, we get these things, and therefore phi is equals to this one. That means this is the angle at which it is working. Okay, fine. So x is equals to, if I consider a steady state at minus phi, and x speed is by t is equals to f sin omega t, x by f by k, x is equals to x naught is equals to 1 by x root over is equals to k, phi is equals to 10 minus 10 inverse this one 2 psi r by 1 by r square. So here what we get is that k is working as a magnification factor, that if the vibration increases, so k, their effect will be, can be seen from the from in the k. Okay, so again this is the plotting by magnification factor to frequency, magnification factor phase angle to frequency. So here we can see that it matches, it get intersected at some point and it doesn't get into it. So this is a generalization thing. We know that. So we force vibration, as I have told you. So this is what assignments and everything you need to do, rectilinear motion. So we have gone for the questions from here. The same things you have to do. Fine. Thank you.